So I'm excited to get this out to you guys. This is a collaboration between myself and Tony Lyons. I wanted to do the PG Bokeh tutorial, best for last here. And in that time, I contacted Tony to see if he could help out of his busy schedule. He's currently working on Black Widow, the Marvel movie, over at Trixter. And he's been nice enough to stay up till 3 o'clock in the morning in Germany and Skype back and forth with me and build this script up from renders that I made. I made some Houdini renders, which involve this pretty much just a pillar in the background. Midground is a fur ball and a fur ball in the foreground. Nothing too artsy-fartsy, but that's what we're going to use. So he put together this awesome script, which you guys have to download for free off my website. So go ahead and go to that link. We also have some links to Tony's website himself, his YouTube channel. Subscribe to that. And also, he wanted me to mention that he has his tool sets link. Please check that out. He has some incredible tool sets and so forth, and he really wants to share all those, and I've reviewed a couple of them and they're incredible. So anyway, let's go ahead and jump right in. We're going to start with these over here, which are not so robust, and that's why they're labeled with red backdrops. And then we're going to finally get to what he uses in the industry. Now remember, Tony's worked for all over the place, ILM, you name it. So he knows how this works, and that's why I specifically asked him, because I'm no expert on this, and we definitely need some top guns here to get through this. So the first one he demonstrates is a straight 2D approach, which will, again, yield the worst results in the situation when it comes to fine here. Again, why do we use PG Bokeh? Well, it's when you got fur characters and you're trying to create synthetic depth of field, obviously, in the comp, it's going to be tricky with those fine little hair details. Now, it's common when you do a depth pass that you want to make sure that it's dilated out enough. So if I go to the depth pass here to this, if you guys remember, specifically Hugo's Desk does a demo of this as well, which is really awesome, and I'll leave a link at the bottom if you guys aren't familiar with it, where it's a good idea to take the aliased version of your depth channel and kind of take this last, pixel value, and expand it out. All right. One little note I want to mention here is this is commonly called real depth. So what does that mean? That means the object that's closest, this foreground ball, is reading at a very small number, and then as I go further back, the number increases to 32. Now the inverse of this is 1 over x, which is common with deep renders. So there'll certain times we're going to use real, and we're going to use 1 over x in regards to the workflow. So he takes the shuffle, he uses his binary alpha plugin, which just analyzes RGB output to alpha, and then he blurs, unpremults, and then merges it over. So if we go to the alpha here, you can see it's just shuffling the depth channel in, and then it just expands it again, and the values are just basically being repeated. So the value of 3.14 in this case is being repeated out. You just want to get every sort of semi-transparent fur basically covered with data. You don't want the data of 000. So again, this has been covered many times in many other tutorials. And then he copies this depth information back in, and it's again sitting over here in the depth channel. And then we get to the PG Bokeh. Now, if you want to download PG Bokeh, you can get the demo version with watermark, which is what we're going to demonstrate here through Pellegrin Labs, so check out the link in the description. So I'll go ahead and put this to it. There's a lot of bells and whistles to this thing. You can see it has bokeh, lens, optical artifacts, kernel, corrective slices, and node. We're going to go through all of these in the second part of this one of two. This is one of two for the PG Bokeh stuff. So anyway, long story short, you can see it's going to be using the depth channel to drive the actual depth of field. And then you have the output type defocus image. Now we have the watermark because we don't have the purchase version. You can feel free to purchase PG Bokeh if you wish. So anyway, let's go ahead and take a look if we put this to focus distance visualization. So in the world of PG Bokeh, the red color is actually the area that's in focus, depth of field, so to speak. And then the foreground out of focus is green, and then the background out of focus is blue. Now you're probably wondering, why is this red here? Well, that's just an error because these values are a value of 0. Okay, so just ignore this stuff out here. All right. So anyway, with that said, you can see we have depth style real or 1/Z. Now in this case, we're going to use real, but when we get into the deep information, we're going to have to flip it because it'll be inverted numbers distance from front to back with 1/Z. It has a multiplier, front multiplier, back multiplier, and so forth. Now, if you go ahead and take a look, we can take the focus plane and change it. So if I put this to like a value of 3.1 and select it, and I can start to use my middle mouse scroll wheel and change the area that's in focus. You can see it's starting at the front of the ball, moving back to the, eventually all the way to the back. See if I can get way back there, because we got to get to, I think we got to get values of like 30. Yeah, there it is. So now the middle ball is in focus, and then finally the pillars are in focus. You see that? So that's just a visualization, but you really always want to have this on default defocus image. So you can see the values of 30. This is in focus. This is out of focus. Now, the multiplier, front multiplier, and back multiplier will not work to anything. As you can see, I'm taking this and nothing's really happening. Unless of course, we come over here to the real-world lens simulation. It's currently using real-world lens simulation. So let me just take this and turn it off. So I'm going to turn off real-world lens simulation, and now this data starts to enact. So the multiplier is going to multiply what's in focus. Let's first go back and just focus this up. So I'm going to go to focus distance visualization, and I'm going to choose a focal plane like I had before of 3. So that's going to probably, let's just get the ball in focus here. So we'll do like 3.1 or something, and I want to get that ball. That's going to be the area that's in focus, the red area. Okay, so let's jump back to defocus image. And you can see the multiplier is just going to multiply the intensity of the blur. If I take this completely back to 1, you could see that this is basically in focus. And again, if I play with the multiplier by looking at it from the focus distance visualization, you can see everything is in focus here with the red, but the more we multiply it, we start to have a very shallow depth of field or narrow depth of field, so to speak. So this you could leave at 1, and the front multiplier, you can see what it's doing. It's blurring the foreground blur more. So whatever is in front of what's in focus will actually blur more and more. And then the back multiplier will increase even more. And you can see it's getting bluer back there. Now that's something that we should best see in a defocused image. So I'll take the front multiplier. Now watch this ball here, the foreground fur ball, and watch as it starts to get more and more out of focus. Now, let's see, there we go. So now you can see it's starting to blur up, and it's still looking like crap along the edges, and that's one of the reasons why we want to do this example. Now, the back multiplier, again, this center ball is in focus, so I'm going to take the back multiplier, and then you'll see the pillars start to go out of focus. Now, again, it looks like crap. How do we know it looks like crap? Let's just take a look, shall we? Let's go to this here. Do you see this artifact here? And I'm going to go back to real-world lens simulation. Again, once I enact real-world lens simulation, which is going to use the scale information, obviously, and the information that either comes from what you dial in or from an exported camera via Limbic or FBX plugged into this camera node. So I'll go ahead and throw that. Look at the artifact you see here. It's nasty. It's not working. So just be aware of that. And that's what Tony's demonstrating here. Is he's basically saying, ain't going to work for the furry creatures. So Pixar's in trouble. Now this is where I want you guys to pay very close attention as we start to move towards quality. Again, it took some time for even Tony to explain this to me, because they found this little quirk, and he had to explain it to me like twice, and I'm like, okay, I get it now. So doing a deep combine as the 2D input of the PG Bokeh won't work either. Once in 2D land, deep data is lost. Very important. Okay, need to use a combination of deep input and 2D input in Bokeh. That's coming along later on. Note this gives you the slowest, worst result ratio. Now, if you guys aren't familiar, the renders are obviously given to you in the file that you download. Is when you render something out of Houdini or any package that renders deep, you're going to render the deep information, and then you're going to render, in this case, an EXR that's deep, and then you're going to render an actual RGB color like this right here, okay, that corresponds. In this case, I had 3 separate elements that I threw together, which is the pillars in the background, the center mid placement ball, and then the foreground big fur ball. And if you guys aren't familiar with deep, check out the link for the awesome deep tutorial I put together to understand that deep doesn't use A over B. It just basically knows where it's at in 3D space based on the information coming from the deep information. The deep information you can see is in R and G, or red and green values here, and it actually comes in the form of multi-samples. So if I come over here, and actually let's go over here to the deep section here and use a deep sample, right? If I go ahead and just plug this into the combine, I can sample this area right here, and you can see that we have a total of 17 samples here, meaning it knows the deep data, depth, distance of this thing, what's behind this thing, what's behind the ball, what's, you know, the back end of the ball, and then the actual pillar. So this is a lot of samples, and again, this information is really, really beneficial. And Tony, as I'll have a couple of videos at the end of this, he explains how most studios don't, they'll get, in this case, deep samples, but they won't have a lot of RGBA samples with those deep samples because the file sizes would just be too big. So anyway, with that said, whenever you take anything in deep and you want to go back into 2D land, you take a deep to image. Now, as Tony was saying, the reason why they use deep information to drive the depth of fields tools in PG Bokeh is that beautiful deep understanding of depth and distance and, you know, little micro details here. The minute you take that deep information and you turn it into 2D, it becomes pretty much just useless because it doesn't have the information there. So we take that and we plug it into the input image. I'll go ahead and plug that in here. And just give it a second here. And as you can see, we still have this nasty artifact. Still not working. And again, like I said before, because we have real-world lens simulation on, this is the information that it's using, okay? So you can drive this by plugging in a camera, which I'll talk about a little bit later. Sorry, I'm pausing the video because I'm burping from eating a very tasty pizza. So anyway, the focal length is now 32 millimeter. The aperture is 6, and again, if I take this aperture and bring it down, you're going to start to see a distance. Now, it's going to take a little bit of time. Let's see if we can kind of see. Doesn't look like it's doing much of anything. So I'll put that back to 6. Now, what matters as far as the actual kind of like taking the foreground out of focus and the background out of focus and multiplying its intensity of blur is the world scale multiplier. Now we have the world scale set to M because this was actually in Houdini and it was based in meters. This was about 3 meters tall. So I'm going to take the world scale multiplier and bring it down, and hence what that's going to do is it's going to start to take this and make it more blurry. Let's see if I have this. And I'm not sure if it's not taking into effect yet. Maybe it's because I'm not sure what's going on here, why it's not doing anything. Anyway, well, let's just keep moving. The example demonstrated on this one, again, we're getting better here, is when you use deep input, okay, it overwrites the color and takes it from the deep. Okay, this is the part that you got to really buckle down for, folks, okay? Notice the grade on the second image is not taken into account. Now, here's the thing. This is a glitch. When you're dealing with PG Bokeh, and let's just undo this, take out this deep input. You know, this is like, here's the actual, you know, setup. I'm gonna, you know, Tony went ahead and graded green, and I put it through PG Bokeh. It's good. Now, the second I take this deep input and plug this in, remember, RGBA information's coming through here, but the second I take this deep input and I plug it in here, notice the grade is not there. We're not seeing the grade information. What's happening? This is completely not being used. Even though we have an input plug in there, and even though we do need to have something in the input, the RGBA information is coming through here, and the deep information is coming through here. This is pretty much useless at this point, but it is just necessary to have something in the input. Don't ask me why. So again, where is the RGBA information coming from? Once this deep input is plugged in, it is coming from the RGB information from the deep area here, not here. This is pretty much, it's almost like a switch node. It's now been switched over to here for both RGBA and deep. So it's kind of stupid, you might say, like, why do we have to even have something here to plug in? And you need something plugged into the input. Weird, I know. So I'm going to go ahead and show you in the PG Bokeh. Now we have this juicy deep input and deep information that's going to help us out. All right. So everything is good. And let's take a look here. So we have real world lens simulation. Let's go ahead and take a look at that area. Look at it. Beautiful. See that? I'll disable and re-enable it. You can see it's going back to this great information. But if I were to compare this with the previous versions, you can see how nasty that is, and I'll put this to 3 so you can see. So 1, 2, 3. So you can see all this nastiness. But now that we have deep information available, we're good to go. Now, we can't have our cake and eat it too. What if we want to actually color grade the RGB information? Well, you could color correct using, obviously, the only color correct node you have in deep, which is deep color correct, and stick it here and do your color correction if you wish. But we don't want to, and the industry people do not color correct in deep. Okay, they color correct in 2D. So we're at sort of a problem here, because we want to be able to color correct RGB, okay, and we don't want to take this and turn it into what we did over here, which is a deep image, because we'll lose that juicy information. How do we color correct this stuff with 2D nodes and then get our solution down through here? Well, it's pretty easy. Now you might think just putting in a deep to image node will actually solve the problem. That's the only real improvement from this one, right? Where you're taking the deep and your deep to image and then you're grading it in PG Bokeh. But guess what? Guess what? It does work, but you still can't color grade. This color grade information will not register. You can see if I look at this grade information, Tony graded it red. Still got that same problem where the RGBA information is switch tracking over here as well as the deep information, and that's it. So the final solution with the whole industry, apparently Tony says this is how they do it, when they do it. Although Tony is, as you see in his interview, he talks about how they use ZD focus, and that usually gets the job done. But when you're dealing with fine hair details and all this, it's important to understand this is how you workflow using PG Bokeh. This final one right here. So let's take a look at it. It's pretty simple. This ain't brain surgery. A deep recolor node. I always call the deep recolor node, it's almost like a reformat node or a copy node. You know how a copy node, you're sort of retelling the computer, or at least the pipeline, what is alpha and what is RGBA. Well, in this case, you're retelling everything. You're redefining what is depth or deep information and color information. So this is where you would do your color correction work, and Tony went ahead and just tinted this green. Okay, and you take the deep recolor node, and then again, you're back into deep again. So he does the same thing for the ball, color grades it a little bit more warmer, deep recolors it, foreground ball, same thing, makes it blue, does a deep merge. Again, this is a necessary evil. Something has to be plugged into the input, doesn't matter what it is, you know, just plug it in and don't complain. So because the deep input it's connected, the RGBA information and the deep information is coming in here, and that's it. All right, just keep that in mind. And again, notice this grade node doesn't work. Again, if we put this in here, it's not taking into account, you know, in this case, we've added some white blasting color. You can see that it's still just ignoring this stuff and going this way. However, it has to be connected. Something has to be in the input. Okay, so this is it. This is the perfect solution. We have very nice edges here. It's looking good. And again, I'll go back into the PG Bokeh and show you now that we have deep information plugged in. When we come over to the real world lens simulation and we take the world scale multiplier and bring it up, it'll actually take away the depth of field. So you can see if we kind of do this, we start to get more depth of field. And then as we take this closer to the world scale multiplier 0.06, this is going to get crazy blurry land. So, and you can see it's still calculating. So this might let's back it up a little. I think I went overboard. Oh, maybe not. Yeah, it's still calculating. There we go. So now you can see, like, wow. I mean, look at all those fine details and hairs and the accuracy of the depth of field. That is why PG Bokeh is the industry standard. And I'm pretty sure the aperture would work as well. As you guys know, aperture, small the aperture, the more shallow depth of field you have, and a very narrow depth of field. So let's see if we take the aperture and bring that down. I'm guessing it's going to become even more blurrier. And I was right. So again, the reason why this stuff wasn't doing anything is because we need to have something in the deep input. Feel free to put comments at the bottom if you've had experience doing this. We're just trying to get this information out, folks. If you guys go online, good luck trying to find a good PG Bokeh tutorial. And that's one of the reasons why I approached Tony on this, because it's going to be helpful for you guys. And the more information you add to help us out, that's great. We're all part of the learning process here. Okay, so I'll put this back to 6 and so forth. Now, as far as what's in focus, okay, what can work is you can finally plug in a camera node. Again, you can export a camera from Houdini, and so you can plug it in. Now watch what happens when I do this. So you can see this PG Bokeh, see the focal length, all this. Watch when I plug this in for the camera. These two go gray, and that is because that, as you can see here, it's being driven by this camera. So this camera has focal length 60. Tony says he usually just has the camera offside, just copy and pastes the values in as opposed to connecting it. But he also mentions how in the industry you'll get from your 3D solver folks a camera that actually has animated let's see if I can find it here. Focal distance. So once this is connected, focus distance is what's dictating what is in where is it going to be in focus and so forth. So if I come over here to PG Bokeh, if I disable the camera here, as far as what is the focal plane, it's being dictated right here. See that? But the moment we plug in a camera, you can see it's grayed out. See that? And that means if you're wondering where the decision of where something is in focus, or the number that determines what's in focus, is this right here. I'll go to my camera, sorry. Is this guy right here, focus distance. So I can set this to 3 instead of 30, because at 30 it's actually taking the pillars and making them in focus. So now 3 units. Again, we can come back to our PG Bokeh and go back to our focal distance visualization. You can see what's in focus. Again, if I take the camera and I take the focus distance and I set it to 30, which is where the pillars are at. See, the pillars are in focus. So if I go back to my camera, and I'm losing my mind tonight, folks. So defocus image, and now the pillars are in focus, and then this is again not perfect. You can see there might be some weird artifacts here. There's a lot of different ways to workflow it. So anyway, with that said, Tony also mentioned, I believe, and don't quote him on this, that when you render the elements as 3 separate elements as opposed to 1, you get more sample information and you're going to get better results in regards to this. So even in this case, it's not working the greatest. Maybe because we're amplifying this too much or something. But that's pretty much it. Like I said, when you disengage the camera, what determines what's in focus is the focus plane under the Bokeh tab. So again, I could put this back to 30 to focus the thing. And one thing I jumped over before we cut to some side notes by Tony is the fact that he mentions it right here. If you do use... trying to think where you put it at here. Here it is. You can see if you do use deep to image, okay, which takes the deep information, converts it to depth, it's going to look a little bit different here. So if you go ahead and take a look at the depth information, you can see it looks a bit odd, right? let's take a look at the depth information of our first example. See how it's just like that? And here, this is what happens when you take deep information, convert it deep to image, and you get depth information. You can see if I put my viewer to deep to merge node, you know, there is, if I can take a look, there is no depth information in here. So deep to image takes the deep information and converts it to depth. Now you have depth, and it has this interesting look. And this information is 1 over Z. This is the one circumstance where you're going to have to take your PG Bokeh and switch it from real to 1 over Z. Like I mentioned before, real is where the values are small for stuff that's close, and then further away, larger numbers. In this case, if we take a sample of the numbers, you can see the value is 0.03 for the furthest thing and 0.36 for the closest thing. So it's an inversion of the way the numbers are growing and so forth. So again, that only is the case when you're dealing with this, and you don't want to deal with this because this doesn't work too well. So all these other examples, like for instance, if we take a look at this PG Bokeh, it is set to real, okay? I will go into detail on the rest of all of these little features and so forth, but again, I'm going to leave you with the maestro himself, Tony, and again, just give him a shout. Check out his YouTube channel. You have nothing to benefit from all the awesome tools and information that he shares. So anyway, to Tony.
Z to focus is usually just as good, and yeah, no, honestly, it's just as good. Sometimes it's faster,
Yeah.
and as long as you plug a kernel into it, it doesn't really matter. Like as long as you plug and I wrote it in the email. We use everyone has optical flares, so we take the folder with optical flares, and they all have the little bokeh things, and we just plug it in there and give it some chromatic aberration, and then it works. It looks fantastic.
So you're pulling that into the kernel input?
Yeah,
of
yeah,
this?
and the
Okay.
Z-Blur has a kernel, a ZD Focus. I forget what it's
ZD
called.
Bokeh,
So the reason why people love this node so much is that if you have a great match move department, they've already done all the aperture and all the focal length stuff, so you can essentially quote unquote plug and play the camera, because it'll have the correct focal length. It'll have it. Sometimes, like at Weta, for example, they even animate the focal distance. So like you can literally just plug it in, and if you have everything physically accurately made in 3D matched, then I guess it'll give you the right bokeh. But that's kind of what I was saying in one of my previous emails, where like people trust it too much. And they're like, why does it look wrong? I don't know, it's physically accurate. And then they don't do anything to fix it, which is one of my pet peeves. It's like, hey, it
So you
looks
find
wrong. I don't
yourself
care how physically accurate
disengaging
it is.
the camera that was given from your department, saying, "Forget it. We're turning off autopilot, and we're coming in here and making changes."
Yeah, a lot of deep renders will only have the first ray of the color, so you can't see. Like if you took your all deep render, you could deep crop it, and I'm assuming we would see what was behind this fur ball in the front. We would like reveal the pillar, but in most deep renders that I've received, it's only the first ray of the color. So when you take away the first object,
There's nothing back
then
there.
all you see is black, because there's
Yeah.
nothing back there. Yeah. Does that make sense?
Yeah. Yeah. I
The
got you.
samples are there, but the samples don't have color information, is basically what I'm saying. Only the first one does.
Oh, so the samples are there, but the color isn't there. Okay.
Yeah, like this, the depth samples exist, but each depth sample doesn't have an RGB color associated with it,
Mm-hmm.
because they want to save time. They want to save space and render time, because it's infinitely bigger. It's like, you talk, if you have to write color information for each sample and you have 14 samples, then your image just got 14 times bigger, kind of thing. Like, so a lot of times they just render the first ray. I'm gonna call it the first ray, like the very first thing you can see. That's the color that like a beauty render, and then they'll only have the depth samples, and that's sort of how they do it. So theoretically, you're like getting the best of both worlds, but obviously not. It's always better to have like this full render like you have, but in production, it's just like not feasible because of the size and the time it takes to render stuff. Yeah.